So we have a couple goals here. We have a function that is, it's just kind of like a random set of lines. So this is just like a general function that we're going to do some transformations on. Our first goal here is to list the transformations in words in their proper order. So hopefully you guys did the homework last night and you feel super good about identifying A, K, D, and C in an equation. Okay, so can somebody tell me what variables we have here? What is the -2 and what is the 1 there? Joey? A and C, very nice, good. So actually, let me just go to this. So we have an A, we have a C. So if we're listing these transformations in words for part 1, my first transformation is A equals -2. Katie? Yep. Very good. So vertical reflection, that's the negative part, and a vertical stretch by a factor of 2. And if you guys want, we can just use like BAFO for by a factor of. Okay, so mathematically, what we're going to do is we're going to take our y's and we're going to multiply them by -2. And then our second transformation, that's when C is -1. Anyone have an idea of what this does? Kendall? Yep. Okay, I don't think we have to indicate vertical here because we're saying down, so I think that implies vertical. But if you feel good about saying vertical shift down, that's fine. Okay, so with our transformation from above, we're taking the y's, we're multiplying them by 2, and then we're going to subtract 1 from them. Okay, so this graph that we have here, it has some points that we can potentially use as kind of like our key points. So I'm going to use these 4 points right here just as points that I'm going to kind of perform transformations to here. Okay, and the points are this. They are 0, 0. This next point is 2, 2. This next point here is 4, 2. And then the last point is 6, 4. Just finding those coordinates there. Okay, so we're going to kind of do this like with the first transformation and show what that looks like, and then we'll do the last part of the transformation and show kind of what that looks like. So if you have maybe a couple extra like different colors that you can use, that would be good, or like highlighters or something that you could use after. Okay, so the first thing that is happening here is our vertical reflection and stretch by 2. What I do is I take my y coordinates and I multiply them by -2. So the x's stay the same, but all the y's get multiplied by -2. So just as a reminder, the x's are the first coordinates here and the y's are the second coordinate. So we're going to do -2 times y to get that vertical flip and reflection, or sorry, the reflection and stretch. So 0 times -2 is 0. 2 times -2 is -4. Same thing here. And 4 times -2 is -8. And I'm just realizing now that this goes way off the graph, which is not ideal. So this one actually goes, so when we go to rewrite the points here, we have 0, 0, 2, -4. I want to kind of move these points. Can you, so her test is in Mr. Penley's drawer, like on the side of his desk, you know where Mr. Penley sits in the learning commons? Can you bring her up there and find it for her and get her started? Okay, if Mr. Ford says anything, just tell him you're my co-op student, okay? Thanks. Okay, sorry, I'm just gonna move these guys, so great, it's not working. Sorry, we're just gonna move these guys over. Yes. We'll do it going down instead. You just need this to be clear, over here to be clear. Sorry. We're gonna have to just extend our graph here. I remember this happening to me before and then I forgot to change it, so it's my bad. Oh. Okay, so we're just gonna extend our y-axis a little bit there. Okay, so we have 0, 0, and we have 2, -4, and we have 4, -4, and then we have 6, -8, so down here. And of course, the graph is going to kind of take on the same shape as the original graph. So it kind of looks similar, but it looks like it's been flipped vertically, and it should look a little bit like it's been stretched vertically as well. So that's our first transformation. Okay, and then what this is telling me to do is take the y's that were already multiplied by -2, and we're going to subtract 1 from them now. So we have 0, so the x's will stay the same again. And now we're just going to take all the y's and we want to shift them all down 1 unit, so we're subtracting 1 from all of them. So really all that's happening is like we're taking these guys, we're taking these guys and they're all moving down. So you don't necessarily have to calculate the points for this. If you want to just shift them down 1, that's fine as well. So this one's now at -9 here. And then you'll connect it again. And that will be your final graph right there. Any questions? Okay. Are we okay to slide to the next one here? Everyone's good? Okay, let's slide over. Okay. We're going to list the transformations for part 1. So what do we have here? What variables? We have a D. We have a K. Okay, so my first transformation is the K value of 2. Can somebody tell me what this does to my graph? Good. Joey? Like in words, what is the transformation?
Oh, is it horizontal?
Close.
Compression?
Horizontal compression by a half. And the second one, D is -1, remembering to switch the sign, so that is a shift left 1 unit. Okay, so mathematically, these are both changes to the x coordinates. So K and D are always changes to the x's. So mathematically, this is telling me take your x's and multiply them by a half or divide them by 2, same thing. And then when we shift left 1 unit, we do half x from the earlier transformation, and then we shift it left by subtracting 1. Okay, so my key points are kind of like already labeled off for us here. There's a point at -4, +4. There's a point at 1, -1, 2, 3, and 4, 3. And we actually don't even have to do these separately. We have the full transformation right here already. So the only thing that we have to do here is we have to take our x's and half them and then subtract 1 from them. The y's will stay the same. There's no A and C transformations. Derek? Negative. Oh yeah, thank you. Yep. Sorry guys, this right here should be a 3, not a -4. So just fix that. Thank you, Derek. Okay, so we're going to take all our x's, we're going to half them, and then we're going to subtract 1 from them. We're going to do it all together. So we'll have our 4 new points, and the y's don't change, so just recopy out your y's here. Okay, and I think it's fine here for us to just use decimals. So we're doing -3 divided by 2 and then subtract 1. We get -5/2, or in other words, -2.5. Okay, so I'm taking each of these x coordinates, I'm dividing them by 2 and subtracting 1. Okay, and then we get -0.5 when we do 1 times a half and then subtract 1 from it. 2 times a half, subtract 1, so moving to this point right here is 0. And then 4 times a half, subtract 1 is 1. And then we're just going to plot our new set of points. So this is our final set of points here. So this is the operations that we're doing to the x coordinates. And I'll do my final graph in just another color here. Maybe we'll do it in red. So just plotting the points. Okay, and then it should follow the same kind of pattern that the original graph follows. So same shape, but it's just compressed a little bit. Okay, use your common sense. Based on the transformations that we wrote in words, does this look like that, like it's been compressed horizontally and then shifted left 1 unit? I think that looks pretty good, right? It looks like it has been compressed like that and probably shifted over as well. So that looks good. Perfect. Okay, last one for us, just to get a handle on these. So what variables do we have? We have an A, a D, and a C. Very good. So we're going to list the transformations in words. The first one is A as a half. What does this do to our graph? Not flip. Vertical compression by a factor of 1/2. So vertical meaning change to the y. So I'm taking my y's and I'm halving them. The second one, our D value is 3. Yeah, thank you. So this is a shift right 3 units. This is a change to the x coordinates, right? So we'll take our x and we'll add 3 to them. And then the third one, the C value is 4. So this is a shift up 4 units. So with our earlier transformation to the y, it's a half y, and then we add 4 to that. Okay, so here are my kind of like key points of my parent function that I'm going to utilize for this guy. So I have 0, 1, I have 2, 5, we've got 4, -1, we've got 8, 1, and we've got 10, 1. Okay, so we have 2 things happening. We have a change to the x happening, and that change to the x is x plus 3. And then we have a change to the y's happening, meaning I have to take my y coordinates and I have to half them and then add 4 to them. So we're gonna take our x's here, each of our x's, and we're gonna add 3 to them. Okay, so let's start with that. So 0 plus 3, that's gonna give us 3, 2 plus 3, 4 plus 3, 8 plus 3, and 10 plus 3. Okay, now we're going to take our y's, and we are going to take each of these guys, and we're going to half them and add 4 to them. Get the second coordinate there. So half of 1 plus 4, that's just 4.5. Half of 5 plus 4, 6.5. Half of -1 plus 4 is 3.5. 1/2 of 1 plus 4 is 4.5. And same value here. So this should be our new graph here after we've done the changes to the x's and the changes to the y's. So we're just going to plot them now. This one right here, it looks like that's not quite going to fit on our graph, so we might just have to kind of like write it over here, which is fine. So 3, 4.5, let's start with that. And then 5, 6.5. And then 7, 3.5. 11, 4.5. And 13 is about like right here, so we'll just have it go off just a tiny bit here. And then same general shape, right? So just connecting the points in a similar way to how the original function looks. Okay. The final question we kind of want to ask ourselves is, does this look like it has been vertically compressed and then shifted right and up? I think so, right? So it's like compressed vertically and then it looks like it's been shifted over and up. So that looks good. Okay, so this right here is basically what we're doing for the rest of the unit, except for the very last lesson. So this should be pretty easy for us to like transfer to any function we could possibly want to do this to, right? Any questions on this before we move forward to the quadratic stuff? Okay. Joey, sorry, did you have a question?
Yeah, so where do we get these equations to find the x and y?
So the equations come from the D and the C and the K and
Or just remember each of them?
so I'll give you like a little kind of summary of how you can set them up in our next lesson. No, not on a test. Okay. So I'm actually just gonna stop.